All right, this particular lesson isn't in your regular textbook. It's going to be a worksheet, but we put a little bit in your notes packet. So grab this. It's right after 3.1, and it's called A.2 or A.2, comparing and ordering rational numbers. All right. So our essential question, how do I compare? That means I put a little parentheses, greater than, less than, or equals. Compare and order, in other words, go from smallest to largest, rational numbers. So we spent all of mods 1 and 2 dealing with integers, and now we just got to take it one step further. And now instead of just positive and negative whole numbers, we are going to add fractions and decimals. Yay! You're excited, aren't you? I know you are. Want to make sure we understand what we're talking about when we use the term equivalent. Equivalent means things that have the same value. If it's two numbers, we often use the equal sign, is the same as, and this will be super obvious once we get in there, but you're going to hear me use that word a lot, not always just equals, and your textbook is going to use the words equivalent too. All right, so write the decimal equivalent to each fraction. So, being a meanie head, I won't let you use a calculator, so I'm just going to use this room over here that I normally have set aside for questions. 1 divided by 5. 5 cannot go into 1, so in front of the decimal point, put 0. But now that you have 10, can go in there twice, and shazam, yay, 2/10. By the way, you know that you could also have done it this way and said, I know that the first decimal place is the tenths place, and if I can see directly how to make an equivalent fraction, there's that word, to go times 2, because 2 over 2 is 1, so I'm not changing the value when I write 1/5 as 2/10. Okay, 2/9. Change that into its decimal equivalent. 2 divided by 9. Now, 9 can't go into 2, so I have to leave that as 0 in front of the decimal. And now afterwards, start going to town. I think we did this one the other day, didn't we? As an example, 9 goes in there twice. That's 18. Subtract, and my remainder is 2. And I add another 0, get 20. It goes in there twice. That's 18. Hopefully you're not having to do this long before you're like, doing. This is a repeating decimal. Boink. Which one is larger then? Well, if I just compared decimals, keep in mind that 1/5 ends at the tenths place. If I needed to put something in the hundredths place, it would be a 0. The repeating decimal, if I went out to the hundredths place, would have a 2 there, and then it would keep continuing on with 2's. Therefore, the 2/9 is the larger value. Okay? If I wanted to explain this with decimals, I would say the hundredths place and I'm not using very good sentences here. The hundredths place is larger in 2/9. Now, you know what? You could also get these two compared by changing them to a fraction with a common denominator. If I went up here and wrote 1/5 and I said, hey, I have 1/5 and I have 2/9, and I want to write each of these with a common denominator, then you'd have to start doing multiples 5 and 9 and see where they have a common multiple. That happens to be 45. And if you change these into equivalent fractions with 45 as the denominator, let's see, I have to go times 9, because 9 over 9 is 1. I get 9/45 here On this one, when I multiply by this 5 over 5, which is 1, I get 10. Haha! Okay? Or you can say that the numerators are, or the 2/9 is larger because 2/9 equals 10/45, which is larger than the 1/5, which equals 9/45. So they're super close, but 2/9 wins. Okay, let's do the same thing with these two rational numbers, 5/6 and 3/4. I want you to write down both ways, okay? Fraction way, I would write here's 5/6, here's 3/4. I need to change each of these into a common denominator now to see if I can compare. So start thinking 6, 12, 18, 24, 30, 36, and so on. It turns out a common or multiple for both of these is 12. So change each of these fractions times 2 times 2. This is 10/12, 4 to 12. Oh, this is the same thing. They're super close. Looks to me like 5/6 is really the larger fraction, not by much, but 10/12 is bigger than 9/12. If I wanted to turn these into decimals and compare them that way, 5/6 means 5 divided by 6. And I get 8 in the tens place. Make sure your decimal point's nice and obvious. And as I start dividing, I got to add a 0. 6 can go into 23 times. That's 18. My remainder is 2. Add a 0. 3 times is 18. My remainder is, see what's happening? This is, oh, how convenient. I had an underline there. This happens to be 0.83 repeating. I'm going to get that little line out of here and fix this. Okay, 0.83. Let me get this big screen again, and then I can extend my page. All right, so that's the 5/6. When you go to do 3/4, 3 divided by 4. There's my repeating bar. Again, it's less than 1, so 0's in the 1's position. I get 7, 28, 2. You might know this one by heart, frankly, and you might not even have to do the long division. 0.83 with 3's repeating is larger than 0.75 because in that tens place, this one is larger. There we go. Your assignment is posted in Schoology. It's a separate worksheet, and so if you don't have it with you or in front of you, go ahead and print it out via Schoology. And as always, good luck and may the force be with you.